going to be able to translate figures and points on a coordinate grid. So we're going to start here with this problem. It's a group of points that we can put together in a figure. So remember when I talked about immediately taking points and being able to connect the dots? Well, today you can connect the dots because we're going to make a figure between these points. So we're talking about a triangle on a coordinate grid here. And we're talking about what's going to be happening if it is translated 4 units to the right. And what we're going to look at here is we're going to see what happens, how we can translate that 4 units to the right. So if we were to use this and take this entire figure and move it 4 units to the right, I'd essentially be dragging each point over 4 units. So these would be where all of my new points would be. And when we translate a figure and we change it around and we say what its new points are, we call those points prime. So this is A prime. It's its new point. C prime is its new point. And B prime is its new point. Now, you may do multiple translations or multiple transformations to a figure. And so you may have A prime, which is its first change, and then you may have A prime prime, which would be its second change, all right? Today we're only talking about translating figures, though. When we're talking about translating figures, we're simply talking about moving them around. There's no rotations, there's no reflections, there's no flips, there's none of that. It's simply like you're working on your PowerPoints for your classes, and you take a picture and you're sliding it around on the page. We'll talk about what happens when you grab the corner and rotate it. Talk about what happens when you grab it and you flip it over. And when you make it bigger or smaller. We're going to talk about all of that stuff later. Today we're just talking about translations. So we're going to start by looking at the original values of the coordinates of these points. So please, somebody with a raised hand, go ahead and tell me the coordinate pair for A's original placement. Where is A originally placed? What is the coordinate pair there? James? -3, 1. And B? Yoel? Location for B. Coordinate location for B. Yes, Yoel, I'm still looking for you to answer this question. James. And the original coordinates for C. Daniela. 1, -3. Yep, so I'm looking at this. It looks like that is actually 2. So just be careful there. So once we translate the figure, it moves over. So what are the new coordinates for A prime? What are A prime? Kenny?
1,
1, 1. And B prime? Felipe? 0, -4. And C prime? Blanca? Count again. Count again. 5. -2. All right, so when we look at these points, we can start to make some realizations about how these points actually move and what changes with the actual coordinates. So how do the coordinates actually change? When we translate the figure 4 units to the right, what actually happens to the coordinates? Isais. So the y stays the same because we're only moving left and right. So that definitely makes sense. And what happens to the x? Johanna. So it increases the x value 4 times. So what we can see is that when we're moving left and right, it only affects the x, and if we're moving to the right, it increases it by 4. So in specific, for this question, how does it affect the coordinates of the point? It increases the x by 4. So we see this is increased by 4. We see this is increased by 4. We see this is increased by 4. So the question is, what would have happened if we had moved it to the left? How would that have changed how the coordinates worked? Jamari, what do you think?
Decreased by 4.
Right, so we're still only moving left and right, so we're only moving in the x direction, but now we're decreasing it because we're moving it backwards. It would decrease the x by 4. So when we think about this, this is a skill that when we're talking about any of the transformations that people who are doing web design or certain types of programming will do a lot of. They think about things in coordinate pairs or in locations, and they think about how they want to move the entire thing to make sure it's located where it's supposed to be, perhaps on a web page or perhaps on a graph, things like that, okay? So looking over here, we now have a new figure. So it's AC or AB, a new triangle, ABC. Let's go ahead and grab the original points for that before we go ahead and translate it. What's the original A? What are the coordinates for the original point A before it's translated? Blanca? 0, 5. And B? Haley? Coordinates for B?
Check it. Look, it's 0 here. For the x, and 1.
So -1 on the x, and it's 2 down, so -2 on the y. C? Yoel? Is that 2, 2? So now this asks us to translate the figure down 3 units. So we would have to move all 3 points down. So that means A prime will be here, B prime will be here, and C prime will be here. So we actually end up with our triangle just slid down 3 points. And how do we expect this is probably going to change our coordinates without even like starting to look at the new coordinate pairs? How do we expect this is probably going to change our coordinates? Yoel?
So they're gonna be it's gonna go up.
Blanca, what do you think?
Going down.
It's going down. How is that going to change our coordinates? It's going to go down, so that's going to decrease it. And what's it going to decrease? The x, the y, or both? So we're only going up and down, which is our y. So we would expect that this would only decrease our y's by 3. So let's look at the new pairs. At A, we're at 0, 2. B prime, we're at -1, -5. And C prime, we're at 2, -1. And so what we can see is exactly what we just talked about, or what you just guessed, is that the only thing that has changed is the y, and it's decreased by 3. So a translation down decreases the y by 3. What do you think would have happened if we had translated it up? How do you think that would have changed the coordinates? Destiny? Yeah, this would increase the y because it's still only going up and down.
Wait.
And so what this does is it kind of, to summarize, it makes us think about it. Increases in movements up and down change only the y, because that makes sense. We're only changing how far it is in the y direction, whereas movements left and right tend to change the x. So looking at this next example, we're already given some points, and we would graph these to check them, but we're not going to actually end up doing that. But this tells us that we have coordinate pairs, and we're taking the entire figure and we're translating it 5 units to the left and then 2 units up. And we want to think about how this would affect our coordinates. And we can think about this in 2 different pieces. First, we move it 5 units to the left. How is that going to affect my coordinates? By moving 5 units to the left, how is that going to affect my coordinates?
Negative.
Alejandro. It will decrease the x by 5. So if we're moving to the left, we're going to say that this is going to decrease my x by 5. So for each of those, I know that I'm decreasing my x by 5. Once we do that, then it tells us to move it 2 units up. How is that going to change my coordinates? I'm going to move it 2 units up after I do that. How is that going to change my coordinates? I'm going to move it 2 units up. How is that going to change my coordinates? Blanca. It's going to be increasing. Increasing what? The y. And so the y is actually over here, so we haven't actually changed the y yet. And what we can see is that we can actually do this all at once, since it's changing just the x and then the y. It's kind of breaking it into different pieces. And so when we do this, we have -3 plus -5 gives me -8. 4 plus -5 gives me -1. -1 plus -5 gives me -6. 5 plus -5 gives me 0. 2 plus 2 gives me 4. 4 plus 2 gives me 6, -1 plus 2 gives me 1, and 8 plus 2 gives me 10. So these are going to be my new coordinates had I moved and translated this point 5 units to the left and 2 units up.